Hi, my name is Piers and today we're going to talk about how the abuse, let's say, of async and await keywords can slow down your application. In a previous video of mine, I talked about the add and the add async methods of Entity Framework. I'll put a link in the description, but long story short, we concluded that you shouldn't use the add async method if you haven't set up Entity Framework to make a call to the database when adding to a DB set, because it can slow down your application. Today we're going to see why. I have a simple console app in here and I have a service. It's called my service, and as you can see from the attributes, I have installed benchmark.net, and in here I initialize in my global setup a list of numbers from 1 to 10, and then I have two methods. One, it's a synchronous getSum method that takes the sum of those numbers and then I return it, and then I use an async overload to do the same thing. So let's go right away and run these benchmarks and see what will happen. So we have our results. Let's take a look at them, and as you can see, the getSum async, not only it's slower, but it allocates more memory. Actually, the getSum doesn't allocate any, and in the long term that will slow down your app more, since the garbage collector will kick in to free that allocated memory. So why that's happening? That's because asynchronous code can introduce some overhead. One of the reasons, for example, is that with asynchronous code, the compiler introduces a state machine that manages the execution of asynchronous flow. There could be other reasons too. For example, the task itself is an object which will be allocated in the heap. But then we have the value task that is a struct, and generally there are things we can do sometimes to improve asynchronous call, but we will always have some overhead. So should we stop using async and await? No, but we should use it only when it makes sense, like when we have long-running tasks or input-output operations. That includes API calls or network calls in general, database calls, files, I/O calls, etc. And that's because this operation take time, and with async code we free up the calling thread to do other work instead of waiting for these long-running operations to complete. And in these cases, the benefits outweigh the overhead. One easily visualized example is when we have a UI. If we perform longer running operations with synchronous code, then we can delegate them to another thread, so they will be executed in the same thread as the UI. But then the UI won't be responsive until these operations are completed, and that will actually froze the UI, and that's bad. So if you are using a library that gives you a synchronous and an asynchronous method to do the same thing as Entity Framework does when adding an entity to a DB set, don't go and use the async one immediately, but first check if that call will be actually resolved to a call that will benefit from asynchronous code. And that's the point of this small video. So if you liked it, please like and subscribe. Thank you for watching and have a nice one.